Good morning, good afternoon, good evening. This is Professor Sistrunk, and I am reaching out to my Cisco students. Okay, so we have reached a milestone. We are in our 4th week of this course, and we're moving out. We're taking care of business, and we are doing it dynamically. Yes, today is dynamic routing. So this is going to be a short session because dynamic routing is really not that complex. It's really simple. We have went through static routing and routing in and of itself. So we know that it's not really that complicated. But a question that I would like to know is this. Do you understand dynamic routing? That is your question for the day. Do you understand dynamic routing, and can you explain it to me? If I asked you, explain to me dynamic routing, would you be able? Hopefully, after this session here and when we meet up, we'll go through dynamic routing. Now, understand this. When we meet up today, we're going to actually walk through a lab, but we're going to more or less set this lab up to focus on dynamic routing, how to actually configure a router so it can dynamically connect to the other routers, you know, the configuration. So I wanted to lead with this out of Wikipedia. Dynamic routing, also called adaptive routing, is a process where a router can forward data via a direct route. That's the understanding I want you to take from this. Don't complicate it. Do not complicate it. It's just one router automatically communicating to another router. So read this particular, and I'm gonna slide my face down. Read this particular definition of dynamic routing so you can move forward in understanding it. It's really simple. So it's now putting it all together is complex, but thank God on this level here, CCNA, you will not have to do that. But as you move up through the chain of command, meaning go from CCNA to CCNP and possibly a CCIE, you will be somewhat responsible for making sure that the dynamic routing works. Now, when I say you will not be responsible for it, what I'm really saying is that you will troubleshoot issues on the network, but when it comes to this type of problem, we normally bring in, as I like to say, quote unquote, the big dogs. Moving forward. So at this point, you just have to understand it. Now, you should be able to explain the function of dynamic routing protocols, explain the purpose of dynamic routing protocols, and explain the use of dynamic routing and static protocols. Right now, you already know the use of static protocols, but you should just basically be able to explain it. You know, so remember, explain function, explain purpose, explain the use. That's all you have to remember. Of course, everything is built out on the routing table, and that's what normally we're going to go to determine the route source, administrative distance, and the metrics of this particular routing procedure. So dynamic routing. So in a nutshell, you know, normally we would talk about the routing protocols and how they connect as far as dynamic routing goes. One of the main routing protocols they like to use in the CCNA classes is RIP. Thank God we won't have to be using that anymore. In the new CCNA program, we really ripped that out. See the play on words? Ripped it out. Yeah, so we won't be using this anymore. We're going to use the protocol that will actually covers the main source of what you'll be doing when you go out there. And when I say source, I'm talking about what you will actually run into and actually be configuring out there. I know you see ISIS here EAGR, or like I like to say EAGR, but it's EIGRP, and you see Border Gateway Protocols. This protocol, Border Gateway Protocol, and ISIS, those normally internet organizations that manage this here. So we like to say these are protocols in the cloud or on a network or stuff like that. But you know, the ISPs normally deal with these two protocols. But EAGR or EIGRP, you know, this is a Cisco protocol, and it's open up. You know, anybody can actually go take a look at it. You definitely can learn how to configure it. But what my point is, the main protocol that you will be dealing with out there is open shortest path first. And we just said in a nutshell, OSPF. RIP, you know, pretty much it has finally met it. It's finally been buried. We don't have to worry about that no more. I mean, of course, people gonna have discussions about it. They're gonna talk about RIP version 1, RIP version 2, and all this and that. But just know, mainly what you need to know about RIP, if you ever run into it outside of a classroom, it's a distant vector protocol. Just like EIGRP, these are distant vector protocol. Both of them deals with IPv4, IPv6. But I want you to home in and focus on learning as much as you possibly can about OSPF version 2 and 3. ISIS and BGP, you're going to learn a little bit about in the last book. In the third book, you're going to get a real good understanding of OSPF. But, you know, just make sure you understand the basics of it in this book here. Moving right along, so dynamic routing protocol, in a nutshell, routers communicate to routers. That's what dynamic routing protocol is all about. One router talking to its directly connected router. And when I say talk, it's really giving that router its presence. And when we talk about presence, we talk about the routing table. This is who I am. This is what I got connected to me in a router that's connected to them. So you got all these routers constantly sending updates to each other. And in the process of these updates, if a router should go down and in the communication chain, that router is down and they're not receiving each other, routers dynamically learn how to reroute and create this situation with other routers. So it's always a router communication, and we need this. We need it bad, because allowing or hoping or praying that someone will do static routing in the cloud or the ISPs and all that, and man, that's a lot of work. That's just too much. Purpose of dynamic routing protocols includes discovery, maintaining up-to-date routing information, choosing best path, ability to find a new best path. And that's what's important. The ability to say, okay, this person is sending some information from one country to the next country. What is the best path? Or the ability to say, my company is next door to the next company, and what's the best path to get the information on that? You'll be surprised how these particular protocols maintain dynamic routing protocol maintain communication and how they choose or select the best path. And right here it says the main components of dynamic routing: data structures, routing protocol messages, and the algorithms. And you're gonna learn in our society, more or less, that's what everything boils down to: the algorithm. Yes, I'm moving my head around, so don't get leery, don't get dizzy. The algorithm is the main breakdown. It facilitates the learning, routing information, and the best path destination. So this algorithm is just basically, and that's everything in our society. If you notice, I was just looking at a news scene the other day where they was talking about TikTok it's not going to sell their algorithm. They're going to sell everything else but the algorithm. Well, that's what we want to buy. We as Microsoft, Oracle, or whoever, we want to buy the algorithm. Without the algorithm, TikTok is not TikTok. Because in the algorithm, you get a chance to learn your customers, learn about your customers, choose the best thing for your customers. And that's the same thing with routing. The algorithm is the thing that decides on how this information should go forward to the next router. So TikTok, what are you doing? Okay, so we had a real deep conversation about static routing uses. Networks often use both static routing and dynamic routing. That's true. Static routing is used as follows. So understand this. We want to piggyback on that. Understand this. There's no one-fit-all solution. We definitely use dynamic routing through the whole process, but what's important is we still use static routing in certain situations. So dynamic routing, where it has its benefits of allowing us to set best paths and routers to know what the next router is doing, directly connected router, we still may be using static routing on our particular network. And routing to and from a stub network, I mean, in certain situations, we just set this up like this. So you see the advantages and the disadvantages of static routing. That's why we use static routing, and that's why we use dynamic routing, and that's why we use them both together. So it says static routing advantages and disadvantages. You see this right here. Here go the disadvantages. For static routing to really take off, it needs to be a small organization, a small company. The bigger it gets, the more complicated it gets, and it's a lot of issues behind that. So just make sure you understand that. We're not going to read this off because we talked about it in the last class. Dynamic routing is the best choice for large networks. Can you imagine GM? I mean, they're everywhere. Can you imagine Tesla? Tesla sending rockets out into space. So we definitely can't have static routing as our main protocol routing procedure. We need to have dynamic routing. And then when you get to the ISPs, hands down, they definitely doing dynamic routing. And as you can see, this can be really, really complex. So we don't have to read out the benefits of it. You know the benefits. Now it does have some disadvantages. It can be more complex to implement. Well, that's why you have a team of experts who step in to make sure you break down that complexity. Less secure. Additional configuration settings are required to secure. And that's where we're going. That's where the whole world is going right now. We want to secure our networks the best way we can. And we've seen by not securing them, it is a lot of problems. So whether you using static routing or dynamic routing, your security level just been enhanced by 10. Now in this day and time, you have to have a robust security team. And it says here, routes depend on current topology, requires additional CPU and bandwidth. Well, if you notice the new routers and switches that's coming out, they are robust. They have robust CPUs, RAM. These routers and switches are dynamic. So this here is this is the least of your problems when it comes to dynamic routing. Now I know some organization or somebody hear this and say, well, we got a massive organization and we just spending so much money on the best routers and switches. Excuse me, you probably a billion-dollar company. Calm down. You got the money for your team. I remember when they didn't like to fund IT departments, but now not to fund your IT department is dangerous. Okay, so we talk a lot about this routing table, and this is basically giving you a picture of how the router communicates. And just remember, the routing table is a table that is on the particular router of all of its connected routes, or connected routers. So it keeps that table. And you can see from here, this here is saying that this router is definitely going out to the internet. So what is this directly connected route? So there's the directly connected route, and it's going into a switch. This is a typical look at how an organization would be. You'll set up with an ISP. The ISP will give you the necessary information to configure your router to go out into the world. And what you will have is that router connecting to switches within your organization. But the main thing is to take from this router here, even though it's going out there, may be connected to routers within your organization. Then they will be connected to switches. So this is basically how your router table will look. Say routing table for R1. So as you can see, this here, you looking at this right here, you looking at this router here, you looking at this router here, and you see the connection that these routers are doing. So this is a command you should know. Show IP route with the pipe command in there, begin gateway. Now if you're using packet tracer, of course you can't use the pipe command, but if you on any of the particular net labs and stuff, you should be able to use the pipe command just to show your routing table. Okay, moving on. So as you can see, routing source, and it gives you the C, it gives you the L, it explains what these are. Identify how the network was learned by the router, and then here's your pink right here, and in your pink it's telling you, identifies the destination network and how it connects. And all you have to do is basically follow this setup and make sure that when you following this setup, you just understand how things are communicating with each other. You know, I mean, you want to know what's a directly connected router. You want it, and that's what the C means. It's directly connected to this particular router. You want to know the static route. Is it ERGRP routing protocol? What protocol is being used? And if you look here, you can see it's directly connected, and it's Giga Ethernet 0/0. So you just make sure when you look at it, just take your time and look at the particular output of the routing table, and you'll pretty much get an understanding, but that's troubleshooting techniques. Make sure you understand moving forward. So that's it. So